Tonight we leave the Earth behind. Beyond the last streetlight, beyond the moon, the universe is waiting. Vast, silent, and patient. This is the story of how it all ends, and why that is nothing to fear. You do not need to remember anything you hear tonight. There will be no test, no urgency, no reason to stay awake. The universe has been telling this story for 13.8 billion years, and it is in no hurry to finish. If you drift off somewhere along the way, that is exactly as it should be. The stars will carry on without you, as they always have. So settle in. Let your breathing slow. We have a very long way to travel and all the time in the world to get there. Our journey begins now. Not at the beginning of the universe, but at the end. Or rather, on the long, gentle road that leads there. A road measured not in years or centuries, but in spans of time so vast that even the word eternity begins to feel small. We begin at home in the present day. And the first thing to understand about the present day is this: you are living in the universe's brief, brilliant morning. It does not always feel that way. The night sky seems ancient and unchanging. The same constellations your grandparents knew, the same moon, the same slow wheel of stars. But the universe is young, astonishingly young. Almost everything that will ever happen has not happened yet. Right now, the cosmos is in what astronomers call the stelliferous era, the age of stars. It is the only era you have ever known, and it is defined by a single, simple fact: the lights are on. Look up on a clear night, far from the city, and you can see perhaps 2,000 or 3,000 stars with your own eyes. Each one is a sun. Each one is a furnace the size of 1,000,000 Earths, pouring light into the darkness, second after second, century after century. And beyond the ones you can see, there are more. Our galaxy, the Milky Way, holds somewhere between 100 billion and 400 billion stars. And the Milky Way is one galaxy among perhaps 2 trillion. The numbers stop meaning anything after a while. That is all right. You do not need to hold them. Just know that the night is full, fuller than any mind can grasp, and every point of light is burning. A star is a remarkably simple thing when you look closely. It is a ball of gas, mostly hydrogen, squeezed by its own weight until its heart becomes hot enough to fuse atoms together. Hydrogen becomes helium, and in that quiet transformation, a little mass becomes light. That light spends thousands of years working its way out from the core, and then it leaps into space, and some small portion of it, after traveling for years or centuries or millennia, ends its journey in your eyes. Every star you have ever seen is a fire slowly consuming itself, and like every fire, each one will eventually run out of fuel. That is the secret at the heart of tonight's story. The universe, for all its abundance, has been given only so much hydrogen. It cannot make more. Every second, the stars burn through hundreds of millions of tons of it. The supply is enormous, almost endless. Almost. But the universe is patient, and given enough time, almost endless is not the same as endless. The age of stars will last for perhaps 100 trillion years. That is about 10,000 times longer than the universe has existed so far. We are not near the end of the story. We are barely past its first sentence. So as we travel forward tonight, deeper and deeper into time, remember this: everything you are about to hear is still to come. The universe you fall asleep in tonight is bright and warm and busy being born. Our first stop lies 5 billion years from now. We are still close to home, as cosmic journeys go, and we are here to say a slow goodbye to an old friend. The sun. The sun has been burning for about 4.5 billion years. It is a middle-aged star, steady and reliable, fusing 600 million tons of hydrogen every second in its core. It has enough fuel left for roughly 5 billion years more. Half its life still lies ahead of it, but not forever. 5 billion years from now, the hydrogen in the sun's core will finally run low. And stars do not go quietly dim when this happens. They do something stranger and more beautiful. When the core runs out of hydrogen, it begins to contract, growing hotter and hotter. And that new heat pushes the sun's outer layers outward, further and further into space. The sun will swell. Slowly, over hundreds of millions of years, it will grow from a yellow star into something vast and red and soft at the edges. A red giant. It will swallow Mercury. It will swallow Venus. It may or may not reach the Earth. Astronomers genuinely do not know. The sun will lose mass as it grows, and its grip on the planets will loosen, and the Earth will drift slowly outward, retreating from the swelling light. It will be a near thing, one way or the other. But by then, it will not matter in the way you might think. The Earth will have changed long before. The oceans will have gone, carried off molecule by molecule into space, 1 billion years or more before the sun ever becomes a giant. Whatever life remains on Earth by then, if any remains at all, will be nothing like us. We are not telling a sad story tonight. We are simply watching the seasons of the universe turn. And here is something gentle to hold on to. The red giant sun, for all its size, will be cooler than the sun you know. Red light instead of white. If you could float somewhere safe and watch it, it would fill the sky like an enormous sunset. A sunset lasting 100 million years. Eventually, the sun will shed those outer layers entirely. They will drift away in slow, glowing shells of gas, lit from within, forming what astronomers call a planetary nebula. For a few tens of thousands of years, our quiet little star will be wrapped in one of the most beautiful structures in the cosmos. Telescopes across the galaxy, if anyone is still looking, will point at the sun's farewell and find it lovely. And when the glow fades, what remains of the sun will be small. A core of carbon and oxygen compressed to the size of the Earth, white hot and bare. A white dwarf. A white dwarf does not burn. There is no fusion left in it. It simply glows with stored heat, the way a stone pulled from a fire glows in the dark. And it cools the way the stone cools. Slowly, unimaginably slowly. That small white ember is the sun's true final form. It will outlast everything you have ever known, and it will appear again much later in our story. So remember it if you are still awake. The little white star, sitting quietly where the sun used to be, cooling by 1 degree at a time. Before we travel further, look around. Even the sky itself is rearranging. While the sun has been living out its long life, something enormous has been approaching, so slowly and so quietly that almost no one on Earth ever thought to worry about it. The Andromeda Galaxy, our nearest great neighbor, a spiral of 1 trillion stars, 2.5 million light-years away, and falling gently toward us at about 110 kilometers every second. That sounds fast. It is not, on the scale of galaxies. Andromeda has been falling toward the Milky Way since before the Earth existed, and it will take another 4 or 5 billion years to arrive. The universe does everything at its own pace. And when it arrives, the word collision will turn out to be far too violent for what actually happens. Stars are so small and the spaces between them so vast that when two galaxies pass through one another, almost nothing touches. Imagine 2 swarms of fireflies drifting through each other on a summer night. That is a galactic collision, not a crash, a mingling. But gravity does its slow embroidery. The 2 great spirals will sweep past each other, trailing glowing ribbons of stars behind them, hundreds of thousands of light years long. They will turn and fall back and pass through one another again and again. Over billions of years, the 2 galaxies will settle, swirl by swirl, into a single, vast, golden cloud of stars. Astronomers who name things long before they happen already call it Milkomda. Clouds of gas will collide where stars do not and compress and ignite. For a little while, the merged galaxy will bloom with new stars, a final festival of light, one last spring before the long autumn of the universe. If the Earth still exists, and if anything stands upon it, the night sky of those ages will be unrecognizable. Andromeda swelling across half the heavens, rivers of newborn stars, the old constellations scattered like leaves, and then, slowly, a new sky, settling into a new and gentle order. Galaxies do this everywhere, all through the cosmos. They drift together and merge and settle. It is not destruction. It is more like two old rivers meeting and continuing to the sea as one. We mention it tonight because it is the last great event our corner of the universe has planned. After Milkomda settles, the calendar of the cosmos grows very quiet, very patient. The stage is set for the long story of the fading stars. And that story is where we go next. We travel onward now, past 5 billion years, past 50 billion, past a trillion. The numbers grow strange, so let go of them. Watch the sky instead. Something is changing. The galaxies are growing dimmer. Not suddenly, nothing in this story happens suddenly, but steadily, like a fire settling into embers late at night. The bright blue stars went first. They always do. The brightest stars burn their fuel the fastest, living for only a few million years. The yellow stars, stars like the sun, last for billions. But one by one, they too swell and fade and leave behind their small white remnants. New stars are still being born for a while. Clouds of gas still collapse, still ignite, still join the great chorus. But the gas is running out. Every generation of stars locks more of it away in white dwarfs and neutron stars and black holes, where it can never be recycled. The universe spends its inheritance slowly, but it never earns more. And so, star by star, the lights go out. The longest-lasting stars are the ones you would barely notice tonight. The red dwarfs. Small, cool, faint stars, none of them visible to your naked eye, and yet they are everywhere. 3 out of every 4 stars in the sky are red dwarfs. The universe, it turns out, prefers to work in miniature. A red dwarf may hold only 1/10 of the sun's mass, but it is a marvel of thrift. It burns its hydrogen so slowly and stirs itself so thoroughly that it wastes almost nothing. The smallest red dwarfs will burn for more than 10 trillion years. Not billion, trillion. 1,000 times the present age of the universe, and then some. So when the great bright galaxies have faded, the red dwarfs will remain. Tiny crimson lanterns scattered through the dark, each one quietly tending its little supply of fuel, outlasting everything larger and grander than itself. There is a lesson in that, perhaps. The patient and the modest endure. But even thrift has its limits. Somewhere around 100 trillion years from now, the last clouds of gas will have been spent, and the last new star will flicker into being. It will live its long, frugal life. And then, when it exhausts itself, something will happen that the universe has never seen before. No new star will replace it. Imagine the last star, a small red dwarf somewhere in the dark, the final fire in an ocean of night. It does not know it is the last. It simply burns as stars do, growing slowly hotter and then slowly dimmer, until at last, after trillions of years of faithful service, it cools and fades and goes dark. And with that, the age of stars is over. The stelliferous era, the only era that has ever known starlight, comes quietly to its close. No explosion, no catastrophe, just the last light going out somewhere in the endless dark. But the universe does not end here, far from it. In truth, the story is only beginning. The darkness that follows is not empty and it is not dead. It is simply quiet. And we are travelers in the quiet now, you and I. Do not be afraid of the dark. The universe after the last star is not a haunted house. It is a sleeping one. Drift with me now through the degenerate era, as astronomers call it, a strange name for a peaceful time. The universe is far from empty. Everywhere, scattered through the blackness, are the remains of the age of stars, white dwarfs by the trillion, the cooling embers of suns, neutron stars, the collapsed hearts of giants, each one a sphere the size of a city holding the mass of a star, black holes, patient and still, and planets, endless, wandering planets. Think of the planets for a moment. Most of them lost their suns long ago, slipping free during close encounters between stars, or set adrift when their stars shed mass and loosened their hold. They sail through interstellar space, frozen and dark, keeping their mountains and their canyons and their secrets. Worlds beyond counting, each one silent, each one waiting for a morning that will never come. There is something restful about them. They have nowhere to be. Nothing is expected of them anymore. The white dwarfs are the last to give up their light. For quadrillions of years they cool from white to yellow to orange to a deep and tired red, dimmer and dimmer, until at last they emit no visible light at all. Astronomers call these final objects black dwarfs. The universe is not yet old enough to contain a single one. Even the very first white dwarfs, born from the very first stars, are still warm. The universe simply has not had time to finish cooling a single stellar ember. That is how young tonight truly is. In the age of remnants, gravity still plays its slow games. Dead stars drift past one another and exchange whispers of momentum. Over spans of time that make trillions of years look brief, galaxies themselves dissolve. Most of their dead stars are flung gently outward, one by one, scattered into the cosmic dark like seeds that will never sprout. The rest spiral inward, drawn toward the great black holes at the centers of their galaxies. And here and there, once in a very long while, something wonderful still happens. Two ancient white dwarfs wandering the dark find one another. They circle closer and closer over ages and finally merge. And if together they are heavy enough, they ignite. A supernova blooming in the endless night, billions of years after the last star died. A single flower of light in an empty meadow, and then darkness again and patience. If protons, the tiny building blocks of matter, turn out to be mortal, even the black dwarfs and the wandering planets will not last forever. Over spans of time written as a one followed by nearly 40 zeros, their atoms would dissolve, particle by particle, gently, painlessly into faint whispers of energy. Physicists do not yet know whether this will happen. The universe is keeping that secret for now. But if it does, then matter itself, the stone and iron of all those sleeping worlds, will simply, slowly, evaporate into light. And when it is done, only one kind of monument will remain. The black hole era, the longest age of the universe and the simplest. Everything that was ever a star or a world or a person has by now become either scattered light or part of a black hole. Black holes have a fearsome reputation, and tonight I would like to soften it. A black hole is not a monster. It does not hunt or chase or devour. It is simply a place where gravity has folded space so deeply that nothing which enters can return. It sits where it is, perfectly round, perfectly dark, perfectly calm. It is, in a sense, the quietest object in all of physics. And in the deep future, black holes are all that is left. Some hold the mass of a few suns. Others, the great ones that anchored the galaxies, hold the mass of billions. They drift through a darkness so complete and so cold that the difference between them and the void around them has almost vanished. Almost because black holes have one last secret: they glow. In the 1970s, Stephen Hawking discovered that black holes are not perfectly black after all. out at the very edge of a black hole, where space itself trembles with quantum uncertainty, a faint mist of particles forever escapes. It is called Hawking radiation, and it is the dimmest light in all of nature. A single black hole shines more faintly than a single candle would, seen from across the observable universe. But it shines. And because it shines, it spins. Particle by particle over eons beyond eons, a black hole gives its mass back to the cosmos. It evaporates. The small ones go first, over spans of time written as a one followed by about 67 zeros. The giants, the great anchors of the vanished galaxies, hold on the longest, a one followed by 100 zeros. There is no honest way to imagine that number, so do not try. Simply hear it the way you hear rain on a roof. A sound somewhere beyond that asks nothing of you. Near the very end of its evaporation, each black hole shrinks faster and faster, glowing brighter and brighter, until in its final second it releases its last burst of energy and is gone. A farewell flash in the darkness. The final fireworks of the universe, spaced apart by silences longer than all of history multiplied beyond meaning. And then one day, somewhere in the dark, the last black hole, the last object in the universe, the last thing with a name shrinks to nothing, flashes once and is gone. The universe is now, at last, truly empty, and our journey is nearly at its end. What is left when everything is gone? Light is left. Thin, stretched, ancient light, the accumulated whisper of every star that ever shone and every black hole that ever faded. Space is left, still expanding, still carrying that faint light apart, spreading it thinner and thinner, like a breath dissolving into a winter sky. Physicists call this the heat death of the universe, another fearsome name for another quiet thing. It does not mean fire, it means evenness. It is what happens when everything, everywhere, has finally settled to the same temperature and nothing remains out of balance. No flow of heat, no flow of time in any way that matters. The universe does not die so much as it finishes, the way a ripple finishes when the pond grows still. Stillness is the natural end of motion. Rest is the natural end of effort. The universe is not being punished, it is being completed. And is that truly the end? Here, at the very edge of the story, honesty requires a gentle answer. No one knows. Some physicists wonder whether empty space itself is permanent, or whether, given spans of time that make everything we have spoken of tonight look like a single heartbeat, a new fluctuation might bloom in the void. A new bubble, a new beginning. Some wonder whether our universe was itself such a bloom, rising out of some earlier stillness. The mathematics allows for dreams like these. It does not yet confirm them. So the last page of the book is blank. And a blank page, if you think about it, is not an ending. It is an invitation. Come back now, gently. Back past the last black hole, past the last star, past the red giant sun, back through 5 billion years to a small blue planet, to a quiet room to you. Here is the truth you can keep under your pillow tonight. All of that, everything we just witnessed, the fading, the cooling, the great hush at the end of everything, is so far away that the entire age of humanity is less than a single snowflake at the very start of a winter that has not yet begun. You live in the morning of the universe. The sun is young, the stars are countless, the cosmos is still introducing itself. And on this particular night, on this particular world, the universe has arranged itself into something that can rest. The same atoms that were forged in dying stars are now, against all odds, lying comfortably in the dark, listening to a story. The stars will keep watch. They are very good at it. They have done it for billions of years, and they will do it for trillions more. So let go of the numbers. Let go of the eons. Let the universe mind its own long business as it always has. Sleep well beneath the age of stars. Good night.